Well, then we will move on to our next presentation from Jason Lowe. Jason's going to talk about networking design, networking the networks. Jason is the Atmospheric Measurements Manager at the South Coast in the Science and Technology Advancement Division. Yay, science. He oversees a network of over 35 air quality monitoring sites, and as we've talked about this morning, they are one of the independent district PQAOs. And they look at both criteria, air toxics, and local impacts of air pollution. Jason is also the co-coordinator for the AQMD monitoring on regional wildfires and other kinds of exceptional events. Jason has a Bachelor of Science in Chemistry and Biology, and then Master's and PhD degrees in Chemistry from UC Irvine. And he started at the South Coast in the laboratory performing technical analytical work. And prior to being in his current position, he led the group that was responsible for quality assurance of the air quality monitoring and laboratory division. So he is well qualified to talk about all of this. So, Jason?
Great, thank you, Karen. So she got to tell the beautiful story of planning as it relates to air measurements, and I get to tell you about the dark tale of how the data is collected and of the geeky atmospheric chemistry that she alluded to. So just to give you a brief overview, I'll continue talking about some of the objectives of the different types of air monitoring and include an overview of the different types of air monitoring networks to kind of give the perspective. She was able to give that satellite viewpoint from outer space, and now we're just bringing it down to like the 10 to 5,000 to give an idea of what the types of programs, the types of measurements that they're producing. Again, you spend an entire morning knowing how to do quality assurance and understanding why it's important to have confidence in the data. It's good to understand what the data is and why it's important to have it at such high confidence levels. Then I'll talk about briefly, because there's a lot of overlap between the different types of networks, to be able to basically connect the dots, connect the different types of networks into potential leveraging opportunities that could be seen. Because in the day and age of reductions in government and lower amounts of money available to be spending on air monitoring, we want to be able to be a little bit more efficient on how we think about conducting these types of activities. So to kind of continue about the objectives of air monitoring, Karen had briefly given an overview of this, is to support compliance with the air quality standards and emission strategy development. She went in detail about the National Ambient Air Quality Standards and how air monitoring plays a role in determining attainment versus non-attainment status. It's also to support air pollution research. A lot of what we've been able to learn was on the benchmarks of science of atmospheric chemistry before, back in the 70s. It's still a learning process. We learned about new things, the effects of PM speciation, moving more into like ultrafine particles, black carbon, and as we push technology into the kind of the next generation air monitoring that was alluded from before. And then lastly, Karen had also mentioned to produce data that we can make publicly available so that the public understands what they're being exposed to or what the potential health implications can be. So there's different types of air monitoring, and there's different types of networks to be able to accommodate the different types of air monitoring. The first is the Ambient Air Monitoring Network, and this is the air monitoring network by which a lot of the larger scale national decisions are based upon. Again, this is the attainment versus non-attainment for the criteria pollutants. It also is important for the state implementation programs and also the PSD plans. There's also these special projects that Karen also mentioned about. These could be longer-term community studies. They could be answering certain questions about some of the pollutants that are of concern in the general region, and also can facilitate, again, research to kind of push that understanding of how air pollution is formed and answer certain questions that the community may have about what the air that they're breathing in. And then there's also event-triggered types of monitoring, which are kind of the nuisance and emergency response. Again, these are accident-related, whether it be refinery flares, whether it be an industrial spill, whether it be wildfires, or just random odors that hit different communities. So there's different applications for the different types of air monitoring data that is produced. Some of it from the main network, such as background level data. It's to understand kind of without different sources or without major sources nearby, what would the air look like? In certain areas, the background levels could be actually higher than other parts of the nation. And it also gives you a good baseline value for which you can compare how your air quality is. So, for example, I think at South Coast, we've predicted like the ozone to be in the background level about 40 ppb. If we're only given to 70 ppb to meet the national standards, that only gives us a small cushion of our ozone inventory that we know we have to play with in order to meet the attainment goals. Another goal is for identifying high concentration areas. So that way, if there's something unusual in the data that says that there's high concentrations, maybe we need to investigate that area a little bit further. Maybe there's a potential source that has been overlooked and needs to be addressed. As you may know, there's a lot of pollution. Some of it's primarily emitted into the atmosphere. Others take some atmospheric chemistry to form, which means that they need to mix, they need some time, they may need some sunlight. So transportation becomes a large role in determining its effects onto the community. So knowing how pollutants are transported across the region becomes an important question to answer some of your planning questions. Part of it is also population exposure, again, to determine if there are potential health effects to the communities that are within your jurisdiction, to know what types of representative concentrations in your area-wide network. Again, just kind of get these values that you know should exist. So if you see some aberrations, it should cause some questions for you to kind of investigate, whether it be looking at data quality or whether it be looking at what has changed in your district that may have caused that aberration. Also to determine source impact. So if there's a new facility that comes in, you can see that, hey, with some little bit of monitoring, if the concentrations change, then you can see kind of what the impact that new source has had. We also like to do some site comparisons, partially if that's more of a kind of planning function. If we need to move from site to site, make sure that the site you're moving into has comparable values, so then you can close down one station and have confidence that the new station that you're opening has similar values. Also, to provide real-time reporting, again, there's a lot of questions that people running events want to know what the air quality is, or people who are sensitive to air pollution. They want to know if they can walk outside, so they do look at the maps. I get at least a few calls every month asking, hey, I noticed on the map that it's orange in my area. Does that mean that I should go walk outside? I'm sensitive, and you know, I want to make sure that if I'm exercising, that I will have less likely a chance of having an attack or whatnot. And the last is also to kind of give a forecast of the future using kind of today's air monitoring data, plugging into some models to determine, okay, what's tomorrow's outlook going to be like? So again, goes into the planning events for people who may be sensitive to air pollution. So there's quite a few monitoring programs implemented at the federal and state level. I've listed some here, which I'm going to go through in detail. But what I want you to do is, because I'm going to be going kind of in a list fashion through the different types of programs, what they're being used for. But as I go through it, see for yourself to see if you can make some of the connections that you can make, whether it be overlapping chemical components, whether it be certain goals. There are, as we go through this, you'll see that there's quite a bit of overlap. So I'll start with the state and local air monitoring networks, otherwise known as the SLAMS networks. These are the ones that have the primary purpose of being compared against the National Ambient Air Quality Standards and meeting the SIP requirements. So the main objective for these is to ensure that the decisions being made versus attainment versus non-attainment are safeguarded. So we're looking about establishing the confidence around the NAAQS levels. So if you notice, like in a lot of the handbook, there's a lot of clauses that saying we increase our frequency, such as for PM, we increase our sampling frequency if you're X% within the National Ambient Air Quality Standards. It's because we need more data to be more confident, so we need more statistical information as we get closer to those air quality standards. We measure the 6 primary criteria pollutants. You can see the network size across the nation is 4,000 sites. That's quite a bit. Concentrated, obviously, in the places that are more affected by air pollution. So you see a lot on the different coasts, with a little bit less in the middle of the nation. and again, hitting on the quality control, quality assurance aspects of making sure that the data across all these 4,000 sites are good, comparable on a national basis. So it is good to adhere to all the same methods. So the whole PKO structure, I mean, we're, again, part of this larger umbrella. Right now we're talking about just the California PKO under ARB, but we're also looking from the perspective of the federal, having US EPA planners look at this entire data set from a national perspective. So we also need to be comparable to sites that are in Utah, New York, Vermont. So to do that, we have to make sure that all of the measurements that we do meet the Appendix A requirements as indicated in the CFR, and making sure that we use monitors and methods that are consistent with that. So I mentioned before, kind of the SLAMs is looking at safeguarding the NAAQS. Well, as you know, the good news is that air pollution levels are declining. But as we do look at the declining levels, there's the scientific questions of, okay, well, we do all of our quality control, so we're getting good data at these higher levels, but as the air pollution levels start going lower, sometimes it compromises some of the detection limits of our instruments, and you know, the modelers want better data so they can better understand the chemistry going on. So EPA recognized that there's this research need to gain that better understanding, so the NCORD network was implemented. So it does support kind of the trace level instrumentation with exception to ozone, but it does look at the trace NO2, SO2, so that way we can ask some of these scientific questions as we get lower and lower levels. It also studies the ecosystem impacts of air pollution, but we're also looking at like NOI, we're looking at PM course and meteorology, again, to answer some of these atmospheric chemistry questions to further our understanding of air pollution and their sources. So this comprises about 80 sites. Some of them are rural, about 25 to 30, and the remaining ones are located in urban sites. Focusing on the ozone questions, the Photochemical Assessment Air Monitoring Stations, or PAMS program, was developed. That is basically looking at the different components, the formation, basically VOCs and NOx, and the formulation of ozone. So part of this program is looking at a large array, namely 57 components of hydrocarbons, also with some carbonyl species, as different components to look against, like source emission inventories, to better understand each of the districts that are in serious non-attainment or above, to further their understanding of what's in their district to address their ozone formation. As you may have heard, those agencies that are lucky enough to run the PAMS program, it's going through a re-engineering process. And what this is doing is, again, kind of optimizing that network, also expanding the reach, because right now the PAMS program was kind of limited to certain agencies. So this kind of gives an idea of reducing the number of required stations and trying to spread it out to different areas to answer some different questions in other regions. Part of it are changing the target list, because looking at the 57 components and comparing to how much actual ozone is being created from these different components, we don't necessarily need to analyze all 57, so they've come out with a reduced priority list to kind of assist with the amount of analysis that is actually being conducted for this. But in exchange, they've added in a few components to look at secondary aerosol formation, as well as some of the air toxics as part of this program. One of the other ideas is moving into faster time resolution, because it helps the modelers who are looking at photochemical transport. Before, I think the smallest window was 3 hours for taking integrated measurements, so 8 times 3 hours in the course of the day during the intensive period. But really, modelers have been asking for hourly data to match our normal air monitoring station data. So to push some of the limits of getting VOC data at the hourly rate, they're looking at auto GCs to be implemented at the stations to be able to match the hourly rate that the other instruments are producing the data. And then lastly, the carbonyls method, there's a lot of issues surrounding that, but with the idea that the carbonyl components are some of the highest ozone-producing compounds, they couldn't give it up, but we're looking into better methods on how to conduct that particular measurement. looking on the PM side of things, because again, I think on the national front, ozone and PM are the two major criteria pollutants that are hardest to attain for. So the PM speciation network was to address kind of the chemical composition and makeup of the PM species. Again, that helps with the chemical inventories so that the planners can kind of assess, where the sources are of PM, how it's formed within their jurisdiction, and potentially how to address some of it within their district. Again, as Karen mentioned, all these programs look at different trends, and this program isn't any different to see how those trends change over time. Also, just give an idea of the different types of pollutants that are measured. You're looking at ions, you're looking at metals, the carbon species, so elemental carbon or organic carbon, and you're also looking at other organic compounds within the PM fractionation. The network is pretty substantial, about 200 sites, although the speciation program itself went under recent assessment, so that network may be shrinking a little bit. In 1999, EPA has the Urban Air Toxics Strategy, which wanted to look at different hazardous air pollutants. And as part of that, the National Toxics Trends Network was established to kind of look at some of the priority hazardous air pollutants, or HAPs, across the nation. So they created about 22 sites, again, in different rural and urban settings, to look at these hazardous air pollutants, whether they be the gaseous species like benzene, 1,3-butadiene, or you're looking at the PM metals. So you're looking at arsenic, manganese, nickel, lead. So you're trying to look at all these compounds that can either contribute towards cancer or developmental types of effects long term. So California also has its own toxics air monitoring program, the California Toxic Air Contaminants Monitoring. So they also have similar goals of measuring these different air toxics, again, to better understand how these are being emitted within California, so we can assess if any of the rules adopted to mitigate some of this have been effective, and just in general to assess the trends within California. So they're looking at similar components as the NAAQS programs, VOCs, carbonyls, the toxic metals, including hexavalent chromium. Next, I'm talking about the Interagency Monitoring of Protocol Visual Environments. That is a mouthful, or the IMPROVE program, which is a lot easier to say. So this was established in 1987 to essentially protect the areas that are sensitive ecosystems, such as national wild parks, and they just wanted to establish visibility and aerosol conditions in the national parks. And they're primarily looking at visibility. So we're looking at the heavier PM components, we're looking at optical parameters, we're looking at PM 2.5, and also regional haze. The network size for this is about 110 across the nation. Next, moving into the Clean Air Status and Trends Network, or CASTNET. And this is a joint effort with NOAA, I believe, to track the effectiveness of, again, these are kind of national and geographic areas that are in wilderness. It's also conducted by the United States Forest Service. They have recently attained the requirements of the Appendix A, so any measurements that they are conducting are defendable against the NAAQS. So your planner should be aware of the data that's being produced from this CASTNET. And they're looking also at the sulfates, nitrates, sulfur dioxide from this network. The network size in that one is 80 monitors across the nation. There's other air monitoring programs that kind of look at dioxins, they look at greenhouse gases, they also look at acids, but as you can see, there's a lot of different types of networks that, if you want more information, you can go to the various web pages to find out more information, but in the time allotted, I just want to at least make you aware that there's other programs out there. Next, I want to kind of move into the special purpose monitoring stations. So this is still data that we would consider putting in AQS because they meet the Appendix A requirements, but these are providing data for special studies to support SIP activities and are designated in the annual network plan. So, for example, if a new source comes in, such as an airport, and you're worried that there could be either lead emissions or something that could affect some of your next defendability later on, you can implement these special purpose monitors to kind of address that, to see, okay, is this something that we need to look at on a long-term basis, or can we conduct this kind of special purpose monitor, do a little study, think it looks okay, and then go ahead and stop the study and move on from there. So these are not permanent, these are not intended to be permanent, but it's again, trying to ask or answer a quick question regarding something that you may find interesting within your district. It is good to note, though, that if you operate these monitors for more than 24 months, they can be used for regulatory purposes, and I'm sure Gwen will say they will be used for regulatory purposes after 24 months. So this is where coding with NAAQS becomes important. Being transparent in the annual network plan is being important. So again, it boils down to, earlier this morning, documentation. So whether it be submitting the data or writing out what's in your plan, it's very important to be very specific for these special purpose monitors. Kind of moving into special monitoring, these are addressing very specific community questions that may be within your region. So some of these may not be related to criteria pollutants. They may be related to nuisances or to unknown emissions from facilities that you may be concerned about. So a lot of times they're looking at toxics, whether it be metals. They're looking at smelly compounds such as hydrocarbons or sulfur compounds. So part of it is designing the small study to make sure you have adequate coverage, whether it be upwind, downwind, or a full gradient study to make sure that you can answer that question. Because you want to be able to answer the question for basically the community, because there's going to be a lot of community concerns usually surrounding these type of special monitoring, and we make sure that we communicate to them, whether it be through the website, town hall meetings, so that way their concerns about air quality are addressed. Then again, to talk to more detail about emergency and nuisance response, again, these are kind of these large-scale events that there's air quality concerns within the region that just happen immediately. They're related to facilities, wildfires, spills, other natural events. We had our own large event in 2012 with the Salton Sea. The entire basin was covered with the rotten egg smell, and we had sent people all across the entire basin because it was basically smelled everywhere across our basin. So obviously, for those who don't know, our district is adjacent to the Salton Sea, which turned over, so all the anaerobic gases that were trapped underneath basically were released, and through our air monitoring data, we were able to show the gradient from the Salton Sea across our basin. So again, the pollutants are related to odors, they're related to air toxics, and unfortunately there's a lot of unknowns out there. So sometimes, to kind of answer the question of, well, can we prepare for everything, or could we have a checklist for everything, whether it be in a QAP or whether it be in a response plan? I think the answer is we do the best we can. We can cite good examples that are frequent, but there always has to be the component of we're going to face something that we haven't faced before, so we just want to make sure that we have a general strategy on how to address that. There's other air agency programs as far as emergency is concerned. There's local CUPAs that we've participated in. There's also the statewide CARPA, or the California Air Response Planning Alliance, that has been formed from ARB, which we're part of. It's a great program where we've been able to develop a set of tools, have a lot of good discussion of what types of training events, again, for emergency preparedness, and sharing that knowledge, which makes us better air response agencies and not just better air regulation agencies. So I kind of went through the different types of networks pretty fast, but I hope you got a strong sense of there's a lot of overlaps of the different types of networks that were being presented, whether it be air toxics, whether it be the criteria pollutants, whether it be just the sheer number of stations. So I want to talk about how they are connected. So part of it is in program objectives. So there's a lot of program objectives that overlap between EPA or state and local. You saw like the NAAQS program earlier from US EPA. California ARB has their own toxics program, so there's a lot of overlap in those two programs. In fact, a lot of sites are similar. You're also looking at overlapping goals within sites, which may have the same pollutants. So for example, you have the SLAMS network, which typically is going to have your criteria pollutants, and your end core stations, which are going to have your trace level, so you can kind of compare the two types of instrumentation. So you would have comparability across your trace and normal instrumentation. You also have interagency interests, like I mentioned before with CASTNET. Ozone measurements are being produced. They may not be part of your own agency, but they are being produced, and you are liable for them because they are, Appendix A defendable. So you want to make sure that you communicate, again, kind of going back to Darcy's presentation, move through that cloud of communication to make sure that people are aware of what data is being produced by your agency, because it may affect another agency, so and vice versa. And then also, again, with the theme of today's talk in terms of the PKO structure, I mean, a lot of agencies are in it together. I mean, as far as the smaller agencies, being able to gain resources from some of the larger agencies, the training session like this to pass on the information from agencies that have a lot of that experience. I mean, I was surprised earlier when seeing the years of experience. You can see an increase and then decline recently. I mean, with the turnover of staff, we're also seeing that too in our agency. But again, we've been blessed with larger agencies, so we can at least transfer that information before people move on. So we try to maintain that consistency. So there's different layers in the air monitoring network. We have the networks within networks because, for example, you have monitors that are run by other agencies. For example, whether it be the PM network, some of the local agencies may collect the samples within their district, but they may send the filters off to another lab for analysis, namely ARB or another lab. So this map kind of shows Northern California, and I want to thank Fletcher Clover for providing the map. But what it shows is the different colors show the different types of agencies, and this is just showing one jurisdiction. But given that there's multiple colors, you know that within this one jurisdiction, there's a lot of data being produced by different agencies. So again, they need to communicate, what data is being produced, and also kind of define the roles and responsibilities if the data does impact some of the other agencies. This involves the multi-agency coordination. Again, talking about NAAQS, but it also may help as far as the co-location of monitors, because if you're a local jurisdiction and you have a co-located monitor, well, that can help the entire PKO because it will also double count as part of that requirement. And then just looking within your own agency, you can look at if you're running multiple programs, such as NAAQS, NCORE, speciation. I mean, we have 2 stations within our jurisdiction that just run everything. So we gain the leverage of having those 2 stations. We don't have to create more stations to be able to fulfill the requirements of the different federal programs. But it also benefits because once you have all those measurements at those 2 points, you gain a whole bunch of information that you otherwise wouldn't be able to gather for that. And then lastly, because of that overlap, you gain some leveraging off of that. So looking at station infrastructure, I'll give an example of emergency response. Because we have multiple stations that conduct continuous PM measurements, whenever there's a wildfire, we can use some of our continuous PM data that's at our stations rather than deploying another EBAM. If we had to deploy the number of EBAMs that we thought we had to without our network, we'd be calling ARB all the time to ask for assistance on some of our larger fires. Again, it also helps researchers. Researchers like using our air monitoring platforms to be able to conduct their studies, but realizing that when they do their research, they're also helping us answer some of the questions that we're wanting to address, but we don't have the time or expertise sometimes to be able to do that. So we're able to leverage the academic community. And the other part is method development. Again, we cooperate with either instrument manufacturers or with other agencies who want to test different equipment. Again, we mentioned kind of the next generation monitoring. We have an active interest in knowing kind of what quality of data that they're producing, what kind of confidence that they have. So having them test at our facilities gives us an idea and heads-up notice of the performance of their different types of sensors. So that way when we start seeing data from community members saying that, oh yeah, we got it from this sensor, we have an idea already of what kind of quality of data that's producing and can maybe educate them if they haven't already, educated on how those sensors can be used for their purposes. Again, for the instrument, I mentioned before that monitors can be used for multiple objectives. One of the things that I've been trying to do and may still try to propose is like for stations that have PAMS and NAAQS carbonyl sampling, they're essentially on the same schedule, so could they account? I know with the speciation assessment that just recently was conducted, one of the recommendations they have was to use the FRM PM2.5 monitor mass rather than measure the mass of the SAS sampler itself. So those are types of things that we can start looking at to, I mean, it's a little bit at a time, but when you start taking small chunks at a time, it will add up to a lot overall when we're talking about these times of, not being able to replace staff or trying to move more towards automation. When I talk about resources, talking about staff, look at monitors that are near boundaries. One example that I have within our district is that we've got a station for hydrogen sulfide that's near the Salton Sea now because of that 2012 event. So it takes one of our operators 2.5 hours just to get there. So, being able to ask a neighboring agency who does that as part of their normal routine to be able to save us 2.5 hours or 5 hours a week just in travel time is tremendous help. So being able to train, knowing that we're on the same methods, and knowing that there's overlap between agencies conducting measurements on sites that are within your jurisdiction really helps a lot resource-wise if you can leverage staff like that. And again, quality assurance, again, the theme of this entire conference is that there's a lot of things that can be leveraged through quality assurance, whether it be auditing, and especially as the new reformulated website has shown, the document repository, again, so we don't have to reinvent the wheel on the documentation end, but kind of the entire message is let's learn off of each other and leverage each other's knowledge and resources so we don't have to reinvent anything as we move forward. So in conclusion, air monitoring programs are diverse, as you've seen with the different programs, but it doesn't understress the importance that each of those different programs needs to have confident data, making sure that they're meeting the different acceptability criteria, because decisions are being made on all of the data with these networks, whether it be showing that emissions inventory is correct, whether it be trying to evacuate a stadium because the air pollution levels are too high from wildfire smoke. I mean, real decisions are being made upon this data, so making sure that they are confident and reliable is definitely cannot be underscored too much in this. And then, like I mentioned before, there's enough overlap in objectives and sites and equipment that you should be able to leverage parts of that to optimize your network design and communication with other districts. With that, I'd like to say thank you, and if there's any questions, I'd be happy to take them before we go on to our break. Yes?
Hi, Jason. Thanks for coming and giving us a speak here. But you talk about special monitoring and nuisance response, emergency response and stuff. And I don't know if you could answer this question, pending litigation or whatnot, but this relates to the Sriracha plant. And I was wondering, one, were you involved in it? And two, what is the monitoring data show? Is it a public nuisance as the City of Urbandale claim, or is it just one or two households just complaining because of personal agenda or whatever?
Right. So that's actually one of the things that we've responded to. And in fact, I have to say that I have actually personally responded along with my counterpart over there, Andrea. We were part of that. We personally conducted special monitoring over at the Sriracha, and we're not talking about, off the sauce. We had inspectors go there to verify whether or not there was nuisance complaints. The city obviously has had a lot of complaints with there. But right now, it was hard for us to determine because, the height of their complaint season is going to be in the grinding season, which is going to happen in a couple months. But we were able to conduct some studies because there was some complaints during the off-grinding season. So what we did was get a tour of the facility to determine what kind of potential odor sources there could be. We went to a couple places where we thought there, some of the sources of odor could be, conducted some measurements there. In fact, Andrea designed a test which had helped them kind of decide on engineering some control measures in preparation for the grinding season. What they had was a mixing room that produced a lot of the garlic and the chili odor, and we had asked a group of staff members to wear masks with different types of filters on them, and anything ranging from HEPA, different MERV ratings, ones with activated carbon as part of the respirator. So we had them go through the mixing chamber or mixing room and rate on a scale of 0 to 5, 5 being uncontrolled. Basically, they walked into the room with no respirator, and 5 was the strength. So what we found is even though the HEPA filters were slightly effective, they were ranked about 3 to 4 on that scale. But when you added the activated carbon, the smell was essentially nothing. So that test allowed them to have some consultation with engineering firms to kind of at least develop their proposed control strategy. So in our discussion, we presented the data actually to the City of Irwindale and Hufeng Foods. So that helped in their kind of assessment and discussions. As far as other actions, beyond that, we haven't been involved. We do know that we'll be back for their grinding season. And also, we've also been there recently to inspect some of the control measures that they've implemented near their grinding areas and given them recommendations based upon an engineering perspective. But that was outside of our shop. It was from our source test engineers that went out to give them feedback. So that's a story that will also stay tuned. Any other questions?
Jason, Errol Villegas, San Joaquin. You spoke a little bit about the PAMS Re-Engineering. Do you know what the timeframes are with the implementation of that re-engineering, the auto GCs?
Right. So I think between the committee that was looking at the re-engineering, the changes are going to be done with the next ozone rule. So it was easier to try to change it within the rule as opposed to change it within the program, because the program's really tied to the rule. So that's when the changes are going to be more implemented. But right now they're doing a lot of the backdrop to the engineering plan. Like they're doing the GC shootout, I think, this year. But I think they've already preliminarily okayed going to the new priority list based upon the MER index. So, agencies who already want to switch to that are able to do that. Any other questions? Oh, got one over there.
Can you explain what carbonyls are and why they're important? I keep hearing that term, and I'm not clear.
Right. So carbonyls are like acetaldehyde, methyl alpha ketone. So they have kind of this double bonded oxygen. It's very reactive. So as far as its ozone production value, it's very high. So if you release those compounds in the atmosphere in the presence of NOx and sunlight, it produces more ozone per molecule than other compounds such as hydrocarbons. Hydrocarbons are typically less reactive. You've got your alkenes and alkynes that are pretty reactive, but your longer chain hydrocarbons, they are less reactive when it comes to production of ozone. So that's what we're looking at. And also, they're also pretty toxic. So that's why it's also higher up on the food chain for air monitoring.
Yeah, I have a question on emergency response. With the focus on emergency response lately with some recent incidents, what is South Coast doing to kind of leverage their current resources to be able to automatically turn on equipment around sources to address an emergency episode?
Sure. At one of our recent monitoring sites, we've been actually in the development for a remote canister trigger, basically. So we have a box that has a canister hooked up to it so that if we receive a call, we can actually, with a press of a button on a computer, be able to activate that canister to take a sample. So that way, usually one of the issues in emergency response is for us, by the time we get the call, by the time we deploy out, you're already looking at a few hours because, for our instance, it may take an hour or, depending on traffic, 5 hours to get to the laboratory, get the equipment, and then deploy out to the location of interest. By then, a lot of times, the incident's done. So if we already know that it's a facility that we may be expecting something, we have either this remote triggered canister that we can do, or we have this continuous monitoring, which is kind of the previous generation. We've already deployed with continuous monitoring. If it sees a high concentration, then it will also trigger the canister samples for further laboratory analysis. Because, again, continuous instrumentation is great for survey, gives you an idea of what may be out there. It's the laboratory analysis, at least currently, that is going to give you the hard information of identification that makes it possible to identify the sources a bit better than the continuous.
Another question.
Sure.
And I hate using this term, but right-sizing the network. You gave so many examples of where there's an overlap. Is the South Coast looking at potentially shutting down instrumentation because an instrument can be utilized for the various programs?
So actually recently it's interesting. With the recent rise in the real estate market, it seems like we're getting kicked out. So it seems like a lot of the places that we're leasing from, they're either expanding or selling. So part of that is we're just getting kicked out. So that's not part of our annual network plan. But I think what the process started earlier with the 5-year network assessment, I want to take that seriously in terms of when we look at the tools, when we look at some of the overlap, some of the lower value sites, have that frank discussion with planning to say how much of this is needed in light of some of the newer EPA initiatives such as near road, near source lead. Because again, the idea needing to be sold that, okay, if we're protecting the NAAQS at where we anticipate the highest concentrations are going to be, then the rest of the jurisdiction should be relatively safe. Obviously, you still want enough spatial resolution in case there's aberrations or new facilities or new sources that weren't identified. So we still want to maintain that. I'm sure Karen could probably say from a planning perspective, it's like, well, every monitor is useful. The question from our perspective, from the monitoring side, well, how useful is it? And could those resources, staff and money, be used elsewhere to solve a higher priority question? I guess is the right way to phrase that.